This is section 8.6, day 2. When solving a rational equation, you may obtain solutions that are extraneous. Be sure to check extraneous solutions by substituting the solution back into the original. Here we're going to solve for x. There's different ways you could solve for x, but first we always like to factor. Then we're going to multiply by a denominator all the way to all three pieces. So I'm going to multiply by x minus 1, x minus 1, and x minus 1. That's going to cross those out completely and leave me with a 7. Nothing crosses out in the middle, so it's 5 times x minus 1. On the end, those cross out, and you're left with 6 divided by x plus 1. Now we're going to come through and multiply by the next denominator. X plus 1, x plus 1, and x plus 1. Nothing crosses out, so you get 7 times x plus 1 minus 5 times x minus 1, x plus 1. And over here, those cross out, so you're left with 6. Now we got to start cleaning this up. 7x plus 7. Here we would multiply through, we could say negative 5, FOIL this together to get x squared minus 1. And then negative 5x squared plus 5 equals 6. Now we need to get all the terms on the same side of the equal sign. So I'm going to add the 5x squared to the other side. I'm going to subtract the 7x to the other side. And I'm going to subtract what would be a 12 to the other side. Now I'm left with this quadratic that I need to factor. We like to factor using a sum and product table. What multiplies to be negative 30 and adds to be negative 7. We know that the signs have to be different to multiply to be negative 30, and the largest one has to be negative. So 1 and negative 30, 2 and negative 15, 3 and negative 10. There's my negative 7 value. So I have 5x squared, a positive 3x, a negative 10x, and a negative 6. This is called factor by grouping. Using the box is another option that you could have. Factor out what you can out of that group, bring down your sign, factor what you can out of this box. A negative 2 times a positive 3 gives you a negative 6. What's inside the parentheses has to be exactly the same. So this still equals 0, by the way. So we're left with x minus 2 and a 5x positive 3. The zero product property tells us to set this up equaling both of these to 0. So x equals 2 and x equals negative 3 over 5. We can check those answers by plugging them back in. When you plug in, what you're really looking for your extraneous solutions is, does one of those answers give you a 0 in the denominator? What I'd be concerned about is x is 1. That would give me a 0 in the denominator. And on this side, also 1 would give me 0. I didn't get those answers, so neither of my answers are extraneous. So for this one, first thing we have to do is factor. This is a difference of two squares. Nothing factors out of the last term. I'm going to multiply through by my first denominator to all three terms. That's going to cross out here. That's going to cross out for the middle term, and nothing crosses out here because this is an x minus 3, this is an x plus 3. So I'm left with 6 equals 8x squared over x plus 3 minus 4x times x minus 3 x plus 3. Then I go through and do it one more time. You could do it at the same time, but I like the organization of multiplying through one at a time. Those are exactly the same, so they cross out. Nothing crosses out here. So you have 6 times x plus 3 equals 8x squared. Distribute this through there to get a negative 4x squared. Negative 4 times a negative 3 gives me a positive 12x. This would be 6x plus 18. Collect my like terms to give me 4x squared. Subtract my 6 across. Subtract the 18 across. And you're left with 4x squared plus 6x minus 18. So that was, I'll rewrite it, 4x squared plus 6x minus 18. Now this is a quadratic. We have to factor it. I do notice that a 2 can come out of all this. So I have 2x squared plus 3x minus 9. Might make it a little easier for factoring. I'll do my sum and product table. What multiplies to be negative 18 and adds to be 3. You know that the two signs have to be different to multiply to be a negative, but the largest one has to be positive this time because the middle term is positive. So negative 1 and 18. Negative 2 and 9, negative 3, let's write down the right number here, negative 3 and 6. That gives me my positive 3. So I'm going to have a 2x squared, a negative 3x, a positive 6x, and a negative 9. So I've put my two terms in the middle. It's called factor by grouping. So what I can factor out of here is an x, left with 2x minus 3. Bring down my sign. Factor out a 3. 3 times 2x. 3 times 3. So I have x with a positive 3. And I have 2x minus 3. This, what's inside the parentheses has to be exactly the same if factor by grouping is going to work. The 2 can't equal 0, so I'm going to use the zero product property to set that to 0, which gives me negative 3, and 2x minus 3 equal to 0, which gives me positive 3 over 2. When I test both of those back here, I notice that a negative 3 would be okay here. A negative 3 would give me 9. Minus 9 would put 0 in the denominator. A negative 3 would put 0 in the denominator again. It only has to fail once, but it failed twice. So this is going to have a small x through it called extraneous solution, and my only real answer is x equals 3/2. Our second page, we're going to come through and factor out what we can here. I see a pattern that might be helpful in this case. I see if I factor out the 3, I'm going to be left with an x plus 2. On bottom, I have an x plus 2, x minus 2. That factors my difference of perfect squares. This side, I have an x plus 1 and an x minus 2. Well, first of all, I see offhand that those are going to cross off. It's going to be very helpful this way. So I'm going to be left with a 3 and x minus 2, x plus 1 with an x minus 2. Now we can cross multiply and be left with 3 times x minus 2, x plus 1, x minus 2. So that puts us at 3x minus 6 equaling x squared minus 2x plus an x minus 2. Collect our like terms, subtract the 3x to the other side, add the 6 to the other side. We're left with x squared. This would be negative 5 and 1 would give you negative 4x. This would give us a positive 4. So how you would factor that apart is to say x minus 2, x minus 2. So x equals 2. And when I plug it back in over here, I see that that gives me an extraneous solution. So if that's an extraneous solution, then this has no solution. There is no value of x that is going to make this equation true. Example number 10. There's nothing to factor apart. So I'm going to multiply through by my first denominator. You have different choices of how you could handle this. 1 times x plus 7. Nothing crosses out here. So we're going to get 12x plus 7 over x. Then we're going to come through and multiply 12 by the x, multiply x plus 7 by the x, and multiply the last term by an x. 12x equals x squared plus 7x minus 12x, and don't forget you'd have to distribute that through to get a negative 7 there. A common mistake is when there's a negative in the problem. So we have 12x equals x squared minus 5x minus 7, subtract the 12x, x squared minus 17x minus 7. Now we look at this problem and we notice that nothing's going to multiply to be negative 7 and add to be negative 17. So I want to check my work real quick here and see if I've set this up right. When I came through and I said 12 times x, that should have been an 84 right here, which would have left a negative 84 here. And a negative 84. Okay, so now let's see if we can factor that apart. X squared minus 17x minus 84. Let's see what happens. So I'm going to try my table again. My negative 84, my negative 17. The larger number has to be negative to get a negative 17, and the signs have to be different. So I'm going to have 1 and 84. I'm going to have 2 and 42. 3, that would be a negative 84, negative 42. 3 goes into 8 2 times, so 28. Getting closer. 4 times negative 21. That gives me my negative 17. So because this has a leading coefficient of 1, I know that my factors are going to work as a positive 4 and a negative 21. Equals 0, so you do the zero product property. So I get my answers of x equals negative 4 and x equals 21, and when you plug them back into the original problem, you'll see that neither answer gives you a 0 in the denominator. So x equals negative 4 and x equals 21 are your best answers. Okay, the last problem, we have a can of paint, and it can you can paint a room in 8 hours. Working together, you and your friend can paint a room in 5 hours. So we're going to set up an equation. Let t be the time in hours your friend would take to paint the room when working alone. So we're going to have 1/8, one room in 8 hours, times 5 hours. We're going to cross out, and the work to be done would be 5/8. Your friend is going to work one room in an X number of hours for 5 hours, which is 5 over X. So we'll bring it over here. What is the sum of the expressions? So we'll take our 5/8 plus our 5x. We'll get common denominators. So we'll multiply by x to both sides. We'll multiply by 8 to both sides. That'll give us 5x over 8x. That'll give us 40 over 8x, which is common denominators. Leaves us with 5x plus 40 over 8x. Okay? This is the amount of work done by you and your friend in 5 hours. So we'll come down to the last part. Well, can you and your friend this is the amount of work that can be done. How long does it take you to do one room? Well, you're going to cross multiply. It's going to be 5x plus 40 equals 8x. 40 equals 3x. So x is going to do a room in 13 1/3 hours.